When I was asked by Teachers TV to teach a pair of maths masterclasses, I decided to tackle two topics that can be both tricky to teach and that students don't always see the wider point of. They're both topics that it's possible to have a lot of fun with, and I'm hoping that's what this group of Year 10 students from 3 North London schools will think too. OK, we're all good at numbers, aren't we? Yeah? Numbers are great. We use them every day. We use them in school. We use them in real life. Do we all feel comfortable with numbers? Yeah. Do we all feel comfortable with algebra?
Did I hear the word algebra? Nasty, scary, X's and Y's. Be afraid. Be very afraid.
Be afraid? Be very afraid. Do you agree, Krishnan? Definitely not. Algebra can be fantastic. Now, we'll move on, first of all, to a little number trick. Think about your birthdays. Write down on your clipboard your month number. So if you were born in September, you can write down a 9. If you're born in December, write down 12. And we're going to multiply it by 5. OK? Multiply your month number by 5. Write down a running total as you go along. Then, add 7. All done that? Easy? Right. Times by 4. Multiply by 4, so that's easy. Double it. And then double it again. OK. Unlucky for some, not for me. Add 13. Got a running total. Now, we're going to multiply by 5 again. Your number's getting quite big now. That's easy, isn't it? Times by 10 and halve it. Last step, I want you to add your day number. If you were born on the 25th of December, your day number's 25. Doesn't matter what month it is. If you were born on the 6th of June, your day number's 6. Hands up who's got a number. Lovely. Mohammed, what did you get?
1110.
You must be one of the oldest people in your year group.
Probably.
September the 5th?
Yeah.
Oh, wow. What about you, Amy?
717.
717, May the 12th. Excellent. OK. I'm right, Anna? You were shocked then, weren't you? It always works. Raheel?
606.
606. OK, you were born on April Fool's Day.
Yeah.
Fantastic! How did I do that? How did I do that? I bet you really want to know, don't you? Yeah. Do you really, really want to know? Yeah. We can use algebra to work out how I did that. And never mind this devil's work. It's not devil's work at all. It's just thinking about things and numbers in a clear way. In fact, algebra is fantastic, OK? What is algebra all about? What is maths all about? Is it about flat caps? OK, look at my market stall. Is maths about fruit? Is maths about numbers? Let's have a look. This is Johnny's market stall. Look at this beautiful collection of stuff. What have we got on here, Raheel? Well, we've got beautiful oranges from Spain. We've got lovely apples from England. What about these, Edward? You like some bananas? Beautiful. All the way from the West Indies. And the most appealing of all, look what we've got here. What have we got? Numbers. Ah, a prime number. I love it. 3. And it's triangular. I love it. What I'd like to do is to come up and select either one of the fruits, I don't mind which one, orange, apple or banana, or choose one number or one fruit, not both. OK, so up you come, put your clipboards down, and come to my market stall. Don't be shy. Everything's going cheap. Excellent. So we've all got either a fruit or a number. So, who went for a number? Hold them up. Not many numbers there, is there? And who went for a fruit? Who's gone for a banana? Beautiful. Like bananas. Excellent. OK. Look at what you've got in your hand. Double it. Keep it in your head. Right. Now add 8. Add 8. Got that? Now we're going to halve what you've got in your head. Halve it. OK. Now, take away what you picked off the stall. Take away what you started with. Could you, Arnold, could you come over here? So the people who chose numbers come over here, and the people who chose fruits make way for them and sit together over this side, OK? So let's see how many numbers we've got. We've actually got 1, 2, 3. We've only got 4. Right then, what did you end up with, Anton? 4. Quadro?
4.
4. Arnold?
4.
OK, you all ended in 4. OK, if we started with 100, what do you think it's going to end in? If we start with 1,000,000? 4. See, it's always going to end in 4.
How come?
Can you prove it? If we tried 1,000,000 numbers, would that prove it?
Probably, yeah.
If we spent our... Probably, yeah. Why? Because you've tried 1,000,000 and you haven't found one that's gone wrong. Sorry, you haven't proved it. If you spent all your life, I'd love to do this, testing every number, I reckon I could get through 7 million before I'm 70. I worked that out. Yeah? 7 million. Would it prove it?
No.
Got a problem. Look at all these fruits. What did you end up with?
4.
You ended up with 4?
Yes.
4.
4?
4.
4? 4? Do you understand why it ended in 4, Adam?
No.
You don't understand. You just guessed, didn't you? You copied them, didn't you?
No.
You did copy him. Adam, come on up. Give him a round of applause. He's going to come and help me. He's the man with the orange. Because he doesn't know what's going on, does he? That's what he started with. He started with an orange. Looks juicy. What did we do? Double it. Right.
Yeah.
Now you got 2, 1 in each hand. Marvellous. What's he got?
2.
Louder. 2. What did we do next? We added 8. Right. Oh, lovely. We added 8. What have you got now? Yeah. Put your oranges together. Can you hold 2 oranges together? Bit tricky. Now he's got 2 oranges plus 8. OK. Next step. Oh, it was halve it, wasn't it? Yeah. This is an important step. How are we going to halve what he's got in his hand? Any ideas?
You put an orange down and you take the 8 and replace it with a 4.
Right, so you halve that hand and you halve that number.
Yes.
And you treat them separately because one's fruit and one's numbers. I like it. Replace it with a 4. I like it. Last step. Take away what you started with.
Orange.
Take away what you started with?
Orange.
I've just taken away his orange. OK, so hang on a minute. He started with an orange and he got 4. OK? You started, Mikhail, with a banana. What do you think you ended up with?
4.
Of course you would. Could you prove it now?
Yeah.
We've just demonstrated, OK, that whatever you start with, whether it's an apple, a banana, or even an orange, these could be any fruits, these could be any numbers. You will always, always end in 4. So that's proof. That's better than trying loads of just numbers and hoping for the best, because the one might come along and it might say, no, it don't work after all. This has proved it's always going to end in 4. That's magic, and that is algebra. Now then, let's just have a think about this. Oh, can you help me with my coat, Adam? It's a bit tight, actually, that. God, they never got it fitted properly after all. Right, we've got an orange and a 4. The penultimate step, yeah? You've got your orange and your 4. And what we did, of course, we took away the orange. It's completely separate to the 4. So we always keep letters or variables, don't we, in algebra, and numbers separately, OK? Separate to each other. They don't mix up. Now, let's just demonstrate this little idea, OK? Could you sit down? Thanks, Adam. Give him a round of applause. Excellent. OK. Now then, who likes cooking? Come on, volunteers. Who likes cooking? Mohammed, come on up. Come on up. You like cookery? Yeah. Brilliant. Excellent. OK, you got your orange. Excellent. Right, well, I'm going to swap your orange for a boring number. Stick it in my cookery bowl. Go on, stick it in and mix it up. Mix it up. Give it a good mix. OK, so we start with a nice bit of raw 4. Nice one. We'll just add a few more numbers. Stick them in. Right, come on. And a few more numbers. Excellent. Mix it all in. OK, what number did you start with that I just gave you?
4.
Was it 4? Pick it out then. Which one was it? You can find it. Is that the 4? Are you sure? There's another pink 4 in there, though. Was it that one?
No, that one.
How do you know?
I'm not sure.
You're not sure?
Yeah.
OK. Why is he not sure? Hands up.
Same number.
It's the same number. All right. Why is it so difficult to find? Who chose a banana? Krishnan. Come on up. Thank you very much, Mohammed. You just sit down. Krishnan. You actually chose a fruit. Get that in the mixing bowl. Go on. Stick it in.
I want to eat it.
Stick it in. I know you want to eat it. OK, but I want you to mix it in first, yeah? To get it all mixed in nicely. Come on. Beautiful. Get that banana mixed up. Bit more vigorous. Come on. Now then, for a banana flavour, we need a few more numbers. Blue's my favourite colour, so I'll have a blue 6 as well. Get it in. Right, mix it up. Close your eyes. Right. Put your hand in and pick out what you started with. You're looking. How's he done that? How's he done that? Round of applause! Magic. Go on, you can have that banana. Don't have another one. How did he do that? How did he do that? Ado, how did he do it?
It was one banana in the bowl.
It was what?
One banana.
It was one banana. But how did he pick it out so easily?
Because bananas and numbers are different.
They don't mix, do they? Obvious. So whatever we start with, whether it's an orange, an apple, a banana, what have I got in here? A bank card, but I'm not going to give you that to start with, am I? Hey? Whether it's N, it could be anything, get it? Anything. It could be anything. N stands for any number. These fruits stand for any number. Now we can feel the power of algebra. Can you feel it? Yeah. Can you feel it? Yeah. Can you feel it? Yeah. Oh, yeah. Now that we're grown up, we're not scared of this N anymore. It's beautiful. Do you want to touch it? It's nice, isn't it? Yeah? Yes. Yeah, feel it? It could stand for anything, yeah? Put your hands on it, lay your hands on the N. It could be any letter. N for number? Sounds good. Right. 3 consecutive numbers.
1, 2, 3.
That'll do. 1, 2, 3, I like it. You know what consecutive means, don't you?
One after the other.
One number following on after the other. Easy. So, shout out the mean. Shout out the mean to me.
2.
Of those numbers. 2. Why do you think it's 2?
Because you have to add them together and divide by how many numbers you...
Ah, right, to work out the mean, you have to add them together, which is 6, of course. OK, and divide by 3. Why 3? 3 numbers, of course, so we get the answer of? OK, what's the median of 1, 2 and 3?
2.
What's the median?
2.
What does the median mean? I'll just throw that in.
Middle.
Oh, the middle number when they're all in order. They are already in order. OK? So the median is equal to 2 as well. Is that obvious? Median equals 2. So give me another set of higher consecutive numbers, Edward.
7, 8, 9.
Yeah, all right, a bit bigger. 7, 8, 9. It's obvious, isn't it? So shout out the mean to me. Come on, add them up.
8.
It's going to be 8, yeah? 7 and 8 and 9 divided by 3 is 8. What's the median? Ado, why?
Is in the middle.
OK, this is always going to work, isn't it? The mean is equal to the median. This is always going to work, isn't it? For any 3 consecutive numbers, isn't it? Yeah. Prove it. Prove it. Prove it. You got a pen, you got your N. So we can begin to do it, can't we? Write down 3 consecutive numbers. I'll give you a clue. Your first consecutive number is that. Write down N. Right, write down the next 2 consecutive numbers. You can put them in a line if you want. So you can start with N. You can write them underneath if you want. What number follows N? In other words, what's one more? Arnold.
N plus 1.
Easy. OK. And then the one after that. Alex, have you got the one after that?
N plus 2.
It's easy. Add them up. N plus 1 and N plus 2. Remember, letters, variables, and numbers don't mix. So when we're collecting these up, we count our N's off, and we count our numbers off separately, and we have a final expression of?
3n plus 3.
So the mean is 3n plus 3, yeah?
Yeah. No. Divide by 3.
Oh, we're going to divide by 3 as well, yeah. 3n plus 3. Yeah, the mean equals 3n plus 3 divided by 3, keeping your letters and your numbers separately. We've got to divide the 3n by 3 and the 3 by 3. What do we get with, Dahlia?
N plus 1.
We get n plus 1. So, whatever 3 numbers we start with, where we've got n, n plus 1 and n plus 2, we always get n plus 1. Yeah? What's the median of n, n plus 1 and n plus 2, which is in the middle?
N plus 1.
So the median's always n plus 1 as well? Yeah. And the mean's always n plus 1?
Yeah.
What have we done? We've proved it. What have we used?
Algebra.
This is getting good. That devil didn't know what he was talking about, did he? Oh, yeah. Now, I'm really into this sort of stuff because I'm a really geeky mathematician, and I think this is beautiful and elegant. It's also handy to get an A or an A star at GCSE because they're looking at proof. All the exam boards were looking at proving number theorems. So that's great for maths, yeah? But how can we use it in real life? Well, this is the real world now because I'm opening my coffee shop. Ho, ho, ho. And look at it. Do you like my sign, everybody? Yeah. It looks nice coffee, doesn't it? Hot and steamy. We also do frappes, yeah? Nice cold coffee. Lovely. Well, this is my new till. It's a beautiful new till, and it's really quick. I can serve a customer in 5 seconds through this till, okay? And I know, because my coffee's so beautifully good, that it only takes customers 30 seconds to drink because it's so lovely and milky. Oh, the frappes are lovely. 5 seconds to come in and 30 seconds to take a seat and drink the coffee. But that's the problem. I haven't got any seats, have I? Not one seat, because I don't know how many to order. But I want to make sure I've got enough. I don't want customers standing up with the coffee and nowhere to sit. But if I get 30 or 40 and I've got loads unused, I'll waste loads of money. I tell you what, I'm just going to pick 4. I'm going to guess. Well, we'll see. Let's open the coffee shop. Right, these two are going to be serving. So, we're going to model the situation because we're not using real coffee. The stopwatch is going to be started by you, sir, Edward. After 5 seconds, Hannah will pass you a mug, and that's your cue to go into my coffee, sit down on a seat and drink your beautiful egg timer, which is set at 30 seconds. So when you've had your time in there, at 30 seconds, it will go a horrible bleep. You can go out the cafe. This is the back door here. I'll take your mug and start washing up over here. Everyone understand? Yeah. We're all ready to queue and we're all ready to go. So are you OK there, Edward, on the stopwatch? Yep. 3, 2, 1, go! First customer's in. 5 seconds. Excellent. Give it a good bing. In you go. Sit down anywhere. Don't mind. Excellent. 2 served up. It's going well. Drink up. Don't let it go cold. Excellent. Yeah, take a seat. Don't spill it. Come on. Oh, the floor's a bit slippy there. Be careful. That's right. Excellent. In we go. Take a seat. You're fine. Take a seat. Just sit down. Take a seat. Oh. We've got to stop. This is no good at all. This is no good at all. Oh, well, you can leave now, but it's too late. I've got 2 customers here standing up. I've got a big queue outside. Has it worked? It's just not happened at all. I know. Let's use Algebra. What are we using? Algebra. Now then, I want S seats. And I want people to pay for P seconds. Paying time. It is a bit big, isn't it? Sorry. OK. This is number of seats. This is paying time. We've got another variable. What is it? Drinking time. Excellent. What should we call that? D for drinking. I like it. These are 3 variables. Now then, drinking time. So, we've got a situation. Seats required, paying time and drinking time. S depends on these 2 other variables. So, that's easy, isn't it? Put your hands up and give me the formula linking S, P and D. Mikhail.
Drinking time divided by paying time.
Drinking time divided by paying time. It's a lot of words to use. What's drinking time?
D.
Divided by?
P.
Right, that's very interesting. I think you could be right, because, like, if I'm the first customer, right, and I go in, and I'm sitting here on my first stool, I've just sat near the end, near the door, bit of a draft, OK, and I'm drinking for D seconds. In that time, there are people coming in at P intervals. So at the end of my D seconds, I have a certain number of Ps who have come in since I've been in, all right? And that number is calculated by just simply dividing the value of D by the value of P. I think he's right. Let's just test this formula. Let's just test this, OK? By substituting values in, D equals, what's drinking time? 30 seconds, isn't it? What about the value of P? 5, Arnold, isn't it? Yep, yep. 30 divided by 5 gives us what? 6 seats. So, that's great. The algebra tells us that we need 6 seats. We've used the algebra to get the answer. So now, let's test it out. OK, 6 seats. I think this is going to work because we've used algebra. 3, 2, 1, go. Excellent. The first customer's in. Sit down. Enjoy your coffee. It's good, isn't it? Carry on. Go on, have a chat with him. Yeah, go on, sit next to him, have a chat. Yeah, good coffee? Nice. Excellent. Lovely, going well. You're doing a good job there. Excellent. Is the till working? Yep. Yep, that's brilliant. Fantastic. Meg's the 5th customer. Are you happy, Meg?
Definitely.
Oh, it's good, isn't it? Good coffee. The seats are getting full. Brilliant. Yep, as one customer's left, the others come in. 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 OK, stop there. Take a seat, Krishnan. We've got all our 6 seats. They are all full. We've still got bleeping coffee behind me, but we've definitely tested it out and it's definitely working. We got to 6, all right? OK, customers. As the 7th customer came in, which is after actually 35 seconds, if you think about when we started the experiment, 5 seconds to pay in, first customer, 30 seconds to drink, first customer. After 35 seconds, he's leaving as the 7th one's arriving. OK? So it's working, isn't it? It's definitely working. And it will continue to work. And everybody's going to be happy. And my coffee shop's going to make loads of money. Problem solved. But there's a big queue, isn't there? Big queue. How are we going to reduce the queue? Let's have some ideas. Come on. Mohammed?
More seats.
Put in more seats. That's a good idea. Yeah. We could put loads in, couldn't we? What? So like put... Is that all right, Mohammed?
One more.
One more. Yeah, sorted. So if we run that experiment again, hang on a minute. Can anyone see a problem with that? It's a good idea. I'd have thought of that.
That'd be empty seats.
They'll be empty. We'll always have 6 in, whatever happens. Think again. We've got a formula here to help us. S equals D over P. Meg?
Speed up the serving time.
Oh. S equals D over P. Speed up the serving time. So what we're going to do to the value of P?
Make it smaller.
Make it smaller. Excellent. Now, hang on a minute. If we make it smaller, if we make the value of P smaller, it's a variable. Can take any value. What's going to happen to the value of S?
Bigger.
It's going to get
Bigger.
bigger. Why?
Because something divided by something will make a certain number, and then if you make the one, the dividing number smaller,
The denominator, yeah?
Yeah.
Smaller.
smaller, then it will become bigger, the answer.
The whole answer will become bigger. Excellent. OK? So if we reduce the denominator, it actually makes the number bigger because we're dividing by less. So it's bigger. And this is great because now I've got problem solved. My seats have bottoms on them. My coffee's getting drunk. And I'm very, very happy. So, are we enjoying algebra? Yeah. Is it fantastic? Yeah. Did it feel the power? Yeah. Remember that birthday trick I did on you at the beginning? Yeah. Have you got your numbers handy? OK, right then. Put your hand up if I didn't do the magic on you. Put your hand up. Let me guess your birthday if I haven't already guessed it. Aha. Yasmin?
709.
709. May the 4th.
Yeah.
Excellent. Are you impressed?
Yeah.
OK, couple more quick.
510.
510. Yeah? March the 5th, yeah?
Yeah.
Brilliant, OK. And one more. Alex.
531.
531, yeah. So you're March the 26th. Is that good?
Yeah.
Is it fabulous? Wow. How did I do it? We used algebra. It's easy. You think we can use algebra?
Yep.
To actually do it? I think we can. Right then. Ooh, a volunteer. A volunteer to do a bit of writing. Volunteer. Go on, Mikhail. Let's just shout out what we're going to write down. So, the month number. I tell you what, I'll start you off. We'll call the month number M. So, Mikhail, times it by 5. Shout out to him.
5M.
5M. What's he going to write next?
5M.
We're adding 7. Letters and numbers separate. Hey, we're going to prove this, aren't we? Keep going.
Bracket 4.
You could use brackets. Very good. Yeah. Or you could times each one by 4. That's a good idea, because you were saying this, weren't you? 4, bracket, 5m plus 7. Expanding a single bracket multiplies each term. Fantastic. Keep going. We'll let Mikhail do the next bit on his own, because it's easy, this bit, isn't it? Go on. No, no. We've got 20m plus 28, and we're adding 13 onto the number bit. Go on. 28 and 13 is
41.
41. Times it by 5. Times each term by 5. 100m. Looking good. Plus 205. Brilliant. Let's add on a day number. What letter shall we use to represent the variable?
D.
D's good. Right. Add on D. See what he writes? Is he going to do it right? 100m plus 205. Thank you very much, Mikhail. Sit down. Excellent. Let me just make that a little bit clearer. Excellent working. Nice algebra use there. 100m plus D plus 205. This is interesting. So say if I started with Independence Day. Does anyone know what Independence Day is? American Independence Day is the 4th of July. What's the month number?
7.
Does it work? M is 7. What's D equal to? 4. For this particular birthday, these variables have particular values. For this example, let's have a look. 100 times 7, 700, right? Plus 4. What's that? 700 plus 4? 704. Oh, yeah, and we've got to add on 205 as well. Let's have a close look at that. Hang on a minute. Hang on a minute. John has been playing tricks for you. 7th month. OK. By multiplying the month number by 100, you automatically get your month number in the hundreds column. And you can use the thousands as well if you're October, November, December, can't you? OK. Automatically, your poor old day is shoved into the units and tens. I'm also adding 205. Let's add that up.
909.
Say again?
909.
Hannah, do you agree?
Yeah.
Palindromic Hannah? Yeah. 909. Palindromic number. I like it. OK. 909. What am I doing in my head? When you give me 909 because you're born on the 4th of July, like Tom Cruise. You what?
Take away 205.
I'm taking that in my head, which is dead easy to do, and you can amaze all your friends. Now, do you know when my birthday is? My birthday is 20 past 12. Hey? 12:20. Get your hand up when you know my birthday. Do the magic in your head. Before you do it, then you'll be in bed, asleep with algebra dreams. Who's got it?
September.
Who thinks they know? Go on.
15th of October.
What do you think it is?
5th of October.
What do you think it is?
October the 15th.
October the 15th, same as 15th of October. How do you know? Because algebra is magical. So that's it. You've done it. You can work out my birthday. You've used algebra to prove you can work out my birthday. You're fantastic. That is it. You've cracked algebra. Yay!